our the other lecture, basic physics, yeah, for regular class. And what is momentum? Momentum is you can call P equal to mass time velocity. Yeah. Momentum, that means how strong something hit. For example, something hit to the other's product. Yeah. For example, ball, you kick it and then hit the door. When hit the door, that means how strong. Yeah. That means this is we can call a momentum. So momentum value is depend on what is the mass of the product, on the mass of the wall, the mass of the stone, and then also yes, the velocity. Yes, when we throw the stone, what is the velocity? Yeah. So from this formula, the biggest velocity, it will give a quick momentum as well. For example, if you hit something, this is slowly motion, the momentum is small momentum. When you hit fastly, it is giving more energy. Yeah.
Yeah.
So I think we can easy to understand how is the momentum is working. In the next slide, so the biggest momentum, it is difficult to, it is hard to stop. Semakin besar momentumnya, the biggest momentum is the hardest we are try to stop. Because the energy, yeah, to hit something is the biggest. And then this is the momentum is changed time by times, because momentum is depend on the velocity. So if the velocity is changes time to time, that means the momentum is will change as well. Yeah. For example, if I hit from the slowly to the faster, that means the momentum is bigger and bigger. For example, this one, yeah, if I'm running the car, this going to slow it down, yeah, that means the momentum is will small until stop. Velocity is zero, that means the momentum is zero as well. So we can describe from the picture, from the V1 to the V2. That means from the velocity 1, for example, the velocity is 0, so the momentum is 0. Yeah? If we back to our formula, P is equal to m times velocity. Okay. What else? When is the stick hit the ball, it's a momentum as well, and it's giving something change from the V1 to the V2. Yeah. The first ball might be is the condition is stop, and then hit by stick, the ball will going to the other direction. Yeah, the same direction. So that means this difference momentum from this point to this point, and this is the external force. We remember the external force in Newton's law is F equal to acceleration, yeah, mass time acceleration. So this means the acceleration is dependent on the mass of the product, the mass of the ball. Semakin keras, ya, it is needs bigger trigger from external force. So if we combine between acceleration and also Newton law, the second Newton law, F equal to m times a. So we got F delta t, the change of the time, is equal to mass times the changes of the velocity. Yeah. F delta t we call impulse. Impulse, that means the changes of the momentum. Yeah. The differences of momentum, first momentum, second momentum minus first momentum. So this is for example, yeah. Momentum exchanges times 2 times. So the momentum is the integral of external force in every time, yeah, t per times. So our conclusion that momentum is m by p, it will difference from time to time, yeah, depending on which the position. So we need to integration the changes of momentum. It's like that. P1 minus P2 is equal to integral of the changes of momentum. The changes of momentum we can explain as F time dt, external force time Okay, yeah, you understand, yeah, about the momentum. For example, that's one. What the kind? This is not football actually. This is the wrong description. What is the kind of the sport? What kind of sport? Cricket or
Rugby.
rugby? Yeah, like Australia, in India, yeah, Commonwealth. Is very famous the kind of sport. Yeah, Ahmed, what kind of sport, Ahmed? The famous one? Football or football, yeah? I think last night, what is Indonesian and Yemen, yeah? 1-1.
But I don't watch it.
You don't?
Yeah, because this day I focus on study.
Yeah.
Mashallah.
Playing Jakarta, yeah? 1-1. Okay. So when we hit something, yeah, for example, hit the wall. So this is the time, and this is the external force, yeah. When we start to hit, maybe the external force is small, and then until the optimum, yeah, comes like this. For example, you hit the pillow, you hit the wall, you hit the window. Start from it, then change time by times. So it's the total of momentum. Yeah. This a little bit more clearly, yeah, how the process we hit something. from the start until the end of the movement. I think it is very important for you when you are studying in industrial engineering, yeah, because you know in industrial engineering our duty is design the product, yeah, and then also talking about safety in the manufacture, safety in the transportation, yeah. So, for example, if you design the product and then this is the casing of a remote control and then you drop it test. So it is very important. You need to understand what the kind of momentum. Yeah. What is the value of momentum? So you can create the kind of design. Yeah. For example, the size, the shape of the casing of the remote control. So it's a safety for the product. Like mobile phone as well, yeah. You put the casing in your mobile phone. The casing is the start from the cheaper to the expensive one. Maybe the expensive one you can compare the cheaper and the expensive one. What is the impact of the drop of your mobile? So when you create a optimum design, you need to understand about the momentum. Yeah. Try to drop it, and then check what is the impact in your mobile phone. You got like a crack or sometimes broken, yeah, the product. So this is very important for us to understand about the momentums. How is the product look like? And also in the safety, like what is the car crash, yeah? You know, in Indonesia is many accidents. Yeah. Every day, have you read the news? Accident by accident between motor and cars, pedestrian and cars, even what is car and train, yeah, many accidents. So when we design the cover or the component that can build safety, we need to to calculate. We need to simulate, yeah, doing simulation. What it look like when the momentum is happening. Okay, I think this one, yeah. Okay. So this is what is, sorry. It looks like the energy, the value of momentum is the same from this from the start to the end, yeah. Jadi what we can call last week hukum kekekalan energi, yeah. The energy is not going everywhere, but it's just only change what is the type of energy. For example, from potential energy to be kinetic energy or to be mechanic energy. Yeah, this just change the type of energy. The momentum is look like as well. Yeah, this is change. For example, two balls A and B is crash. Yeah, A have mass, A have speed, yeah, velocity, and also B, yeah. So it will change the velocity. So we can see this one. A is faster than B. When the hit, B is going faster. Yeah. So after crash between A and B, it will produce a different value of velocity because we got the input external energy, yeah, external force. Okay, I just want to show you because I need to leave the class a moment and then back to this class ya. Jadi saya mau pergi ada pertemuan dengan Pak Dekan sebentar 15 menit ya. Kamu pahami, nanti kita melanjutkan kembali ya. Yeah. For example, the kind of the grass, yeah, it's the same. I think the same mass, the same speed, and then hit together. Look what happened, yeah.
Sorry, question. From previous class, you asked us to make a group. Each group 3%.
For assignment, yeah.
For assignment.
Yeah. Okay. After I back from the gym, I will we can later, yeah.
Okay.
Okay, yeah. I will leave it a moment, yeah. Okay, sir. I will take 15 minutes, yeah. I have a meeting. That is before what happened. M1 and M2, yeah, the first wall and the second wall have the same direction, yeah, going forward the same direction. M1 have M1, the mass of this ball and the velocity, and then it will hit the big one, yeah, the bigger than the M1, that is M2, and have a velocity 2. So from this graph, we can see that M1, because the velocity is higher than V2, so that means it will hit the M1. Yeah. When hit, that means what is punch, give energy. Yeah. Making a momentum. So the momentum is it will give the impact. The big one, it will have. I think the velocity is bigger than before, yeah, because have a momentum hit by ball one. So this is the final after crash, and one because have the small compared to the second ball, so it will change the direction here. Yeah. And then yes, it will produce a new velocity. Yeah. This is bigger than V2. Yeah. V2 action bigger than V2. So this is the momentum. The before crash, yeah, and this is the momentum after crash. This is the total of energy kinetic after crashing. The mass is still the same, ya, di masanya tetap sama. Okay, then I think it's no problem to understand this one. Yeah. So it's the same direction but difference of the width of the ball. It will give different impact. What happened when M1, yeah, the mass of M1 is bigger than M2? What happened? And we change the position of the ball. Yeah. So this is M1 bigger than the ball of M2. Yeah. What happened?
It goes the same direction.
After crash, I think it's all still the same direction. Yeah. For example, this one. So still the same direction, yeah. Yeah. That's one, and then yeah. This is going faster, yeah.
Yeah.
V2 is going faster, so V2 absent bigger than V2. And what happened in the biggest one? V1 absent, small, yeah?
Yeah.
Because give energy. Remember, the energy is not going anywhere, but they will change the type of energy or the value of energy. So it will like that. So it's the what happened, different kind of the position of nuclear because of different ways. Okay, this is the kind of situation we can explain the kinetic energy after, before and after crashing. Sorry, the background, yeah, okay. The background is red, not a little bit, but you can still read it, yeah. This is the momentum after, and yeah, you know the energy is always the same. So after and before, yeah. So finally we find this formulation. And then there are many types of crashing. The first one is sorry. What is lunting? Lunting in English is what is bouncing, yeah? Bouncing. The 100% bouncing, that means what is the same height, yeah? That you drop the ball and then it will up again, yeah, in the same height. Yeah. So that means in bahasa we call lenting. So when this condition, I will play the animation. This is before when crashing is happened and after crashing. This one, the animation. Yeah, this is lunting. That means they have the same energy, and what is one the other ball is not take the energy. Yeah, so we can call lunting. Yeah. Look, the mechanic energy is always the same value. This is the first condition, kind of a crashing. So what happened in the second kind of crashing? This is part of Ponzi, ya. Jadi tidak semuanya lunting. The elasticity is between the value of elasticity is between 0 and 1. So this is the animation. Yeah, look. Yeah. Yeah. Not like when I'm drawing this one. That's when fully called lunting. Yeah.